So we looked at phytocannabinoids from the cannabis plant. Now let's look at other plants that may have some interaction with the cannabinoid system. Now, whether that be they actually have some type of phytocannabinoid in them, or they just interact with the phytocannabinoid system once we ingest them. And typically these are plants that have traditionally been used as plant medicine as well. And we're just starting to understand how they work. This list is actually quite small right now. It's based on a study that was done a few years ago, and just kind of looking at a handful of plants. So I thought it'd be kind of fun to go through these because it helps to sort of broaden our awareness of plant medicine and how, things that we don't know, we're actually, the cannabis plant is going to be the bridge to knowing how other plant medicines work. So these are called cannabimimetic plants, and they've been documented to interact with the endocannabinoid system in some way. It's likely we're going to find a lot more of our plants that work this way as well. But right now we'll start with just these few plants. Now I've listed them with their Latin name, and you don't have to remember the Latin name. Sometimes the common name is a little easier. The reason that botany, or when we're referring to plants, we actually use Latin names is because around the world, the same plant can have common names or colloquial names that are sort of common to that area. And so we might not realize that we're talking about the same plant. So in botany, we have, that it's an ongoing study, but it's been around for a century or two now. And it just helps to have a common language, using that Latin as a common language so that we always know that we're talking about the same plant. So this first one, the common name is Spilanthes. Acmilla oleracea is the Latin name for that one. Spilanthes is also known as the toothache plant, or paracress, or electric daisy. So it does have quite a few names. It's quite a beautiful flower on there, you can see. It doesn't grow in Canada naturally. You can grow it in your house. It's more of a house plant here, a little bit finicky to grow, but it does grow in the wild in warmer climates. This one contains a cannabinoid-like compound that stimulates CB2 receptors. We know that Spilanthes can be used as an effective pain relief, especially for inflammatory or shooting pain. And that's why it's used a lot for what one of its nicknames is, toothache plant. It's very good for healing things within the mouth. It's not a common plant medicine that you can find at all of your health food stores, but if you go to a herbalist, often herbalists keep that in stock. Or if you get any kind of herbal mouth products or toothpaste or mouthwash, those kinds of things, often Spilanthes will be a product of that. So it is a not as well known or popular plant, but as herbalists do know quite a bit about this one, and it's a fantastic, beautiful little plant. Our next one, Echinacea, a little more well-known, the Echinacea plant. That SPP just beside Echinacea, that just refers to all of all the plants that are in the Echinacea species. And there's a few of them, Echinacea purpura, Echinacea angustifolia. So there's a few different ones out there, but we're referring to all of the Echinacea plants in this one. We also know that this one also interacts with the CB2 receptors, and we know that CB2 receptors are really well connected with regulation of the immune system as well as the inflammatory response. So any kind of Echinacea medicine, and this is very popular at health food stores, you can pick this up. It's a really great one at those very beginnings of colds and flus, like the little scratchy throat, or maybe just feeling a little bit tired and run down. You've been exposed to someone who's been sick. This is a great one to take at the beginning to sort of boost the immune system up and maybe help kick some of that out as well, likely working through CB2 receptors on our immune system. Heliscarum, you often see this one a little bit more in the essential oil area. And it has an interesting smell as an essential oil. It contains a compound similar to cannabigerol, so that CBG. Remember CBG being that mama cannabinoid that we have. So the unheated CBG is present in the developing plant, but not so much in the mature plant. So just like our cannabis plant as well. Strong potential for treating depression and other mood disturbances, and a potent anti-inflammatory properties. So this one, again, you won't see this one as much in like pill form or those kinds of things, but you do see it quite a bit in the essential oil industry. Piper methisticum cava, or cava is another name for that. This plant was actually banned in Canada for a little while because it is a potent muscle relaxant. It does it interacts directly with the CB1 receptors, or at least one part or one compound in there interacts directly with the CB1 receptors. So again, we know that CB1 receptors we find them throughout the body, but mostly on the central nervous system, so the brainstem and the brain and the spinal cord, those areas there. It's, like I said, it's a potent muscle relaxant, so it's obviously working on the immune system. It also has cavalactones, which are similar to cannabinoids, other cannabinoids that we find in cannabis, and these bind to locations in the brain associated with addiction and cravings. So I don't know of any studies right now using kava to help people get off some of the addictions that can be a problem, but definitely Piper mysticum is very well known in the herbal industry, basically for muscle tension, for bringing down muscle pain, just overall relaxing of the muscular system. Piper nigrum, which is a very common black pepper. Everybody probably has some sitting in their spice cupboard or on their kitchen table. Likely people are using this every day, just in small amounts, kind of adds a little bit of a spice to our food. It has a compound caryophyllene, which we also find in cannabis as well. So if you remember, caryophyllene is one of the terpenes that we find in cannabis. Also, if you remember when we talked about caryophyllene in the terpenes, caryophyllene is one of those ones, like, they don't really know, does it act as a terpene in the body or does it act as a cannabinoid? So this is one of those compounds that they don't quite know how to categorize it yet, but we do know that it's very anti-inflammatory. Of course, all peppers in the pepper family, so the hot peppers and the sweet peppers and some of these smaller spicy peppers, they all are very anti-inflammatory when you include those in your diet as well. Our next one is Japanese liverwort, Radula marginata. Again, it's got a compound in there that is similar to THC, and it binds with the CB1 receptors, but you don't get any psychoactivity with that. So that's interesting, right? If it's similar to THC and it binds to some of those same receptors, but it doesn't cause psychoactivity, we've got a lot to learn about the endocannabinoid system. Rhododendron, the rhododendron plant, and a lot of people have them in their gardens. It's a beautiful kind of bushy plant that has big, beautiful flowers on it. Has two cannabinoid-like compounds in it. And these have been isolated just from this one type of rhododendron, so Rhododendron anthrapogonotes. Love those Latin names. It's shown to be effective against staph infections and some cancer cell lines. So again, we have a lot more research that we need to do, but lots of promise for using the common rhododendron that's sitting in your garden that might be a really good plant medicine. Now, we don't know enough about this one for you to go out start adding that to your salads or anything. Please don't do that. But there's some promise in there. Theobroma cacao, which is where our chocolate comes from, gained popularity in the last few years. It's become well known as a superfood. A lot of people are incorporating chocolate, and I'm not talking about the chocolate bar chocolates you get from the corner store, but real true chocolate that maybe doesn't have as much sugar added to it. It's actually quite a bitter plant on its own. This contains an FAAH inhibitor. Now remember, FAAH is that enzyme that will degrade the anandamide in the body, so that endocannabinoid that we just make, that bliss molecule, it will degrade that. So if we inhibit the FAAH, there's not enough in there to degrade the CBD-like activity that's going on with that. Some people say that cacao or the cocoa plant actually has anandamide in that. I'm not sure that's 100% correct, but again, we need more research. We need to battle that out at the scientific level to figure out, is this just stopping the anandamide from being degraded, or does it actually is it a supplemental type of anandamide? We don't know. Just that a lot of us know that chocolate makes us feel really good when we eat it. So now we're starting to understand a little bit more why. Here's a black truffle. Not as common. It's very expensive. Really interesting industry around the truffle industry. There's special dogs that have been trained to kind of dig up the truffle plants. This contains a compound similar to anandamide, so again, that bliss molecule, and it does bind with the CB1 receptors. That could be why it's so well sought after, is because it does help people to feel good without sort of going into that impaired state. So it could be the popularity of the black truffles. Next, we'll talk about some synthetic cannabinoids. So synthetic cannabinoids were actually created in the lab to target cannabinoid receptors. And a couple of examples of those have just very chemically names, HU-210 and WIN55212. A lot of these are not, there's not a lot of synthetic cannabinoids, but they were created to get around the prohibition of doing research with the actual plant. So the synthetic version was not prohibited, but the actual plant one was, which is it's an interesting area to kind of think about, to wrap your head around. But they wanted to study this, so they had to create synthetic versions, and so we've learned a lot from these synthetic labs. HU-210 was created in 1998, so probably the first synthetic cannabinoid that was created. Dr. Meshulam's team, of course, we've learned about Dr. Meshulam and all of the early research that he did into cannabinoids and sort of set the stage for the discovery of the endocannabinoid system. The interesting thing about these synthetic cannabinoids is they are much, much more potent than the cannabinoids that you would get from the plant, to the tune of hundreds of times more potent. This one has been used as an antidepressant, anti-anxiety, and an analgesic, so that's pain relief. And it's shown to prevent inflammation of Alzheimer's disease, so that inflammation within the brain. The interesting thing about these synthetic ones is because they're so much more potent, it makes them much more dangerous than the actual plant itself. And that could have, because so much studies have been done with the synthetic cannabinoids, that could have skewed the results over the years of how we view cannabis medicine as being dangerous, because a lot of the studies were done with an analog of the plant or a synthetic version that is hundreds of times more potent. So of course it's going to be more dangerous. So we have to kind of get past all of that history and start doing the research with the actual plant material in concentrations that you would actually find in nature rather than these synthetic high potency plants. So some benefits of synthetic cannabinoids. Why do we have them? Well, it's more economical to create the less abundant cannabinoids. So in the future, things like we were talking about CBG or CBC, so some of those cannabinoids that maybe aren't as abundant in the plant. So we can create synthetic ones of those cannabinoids, and then we can get them in higher concentrations than if we were to try and grow plants and then extract them out of them. So that could be one a great benefit of synthetic cannabinoids. Of course, the original reason is they are used for research purposes when plant-based cannabinoids were, and in many countries are still, illegal. You can get a uniform potency or uniform consistency across batches. That's really important especially when we're doing clinical trials. We don't want any variation in the medication that can skew the results. They are considered pharmaceutical grade, for better or worse. So this opens up the door for pharmaceutical companies to be putting a lot of money into research, because a lot of times pharmaceutical companies don't want to research a plant that you can grow in your backyard and make a simple tea or extract out of it, because it's hard to make their money back after they put millions of dollars into doing the research into it. Often used in clinical studies, which garners trust of the product. So when we're doing these, a lot of clinical studies that are done, they'll use one particular product, one particular brand name, very certain specific dosage. And that means we have consistency across the board. And then so when people who are like looking through studies to treat find methods of treating health conditions, so seeing if somebody else has gone through this before, then they can kind of trust that that product, because it has shown good results in the clinical trial, they can trust that product is going to likely give similar results in real life outside of a trial. So there are over 100 cannabinoids in the plant, most of which are too costly to extract. While THC and CBD can be readily extracted from the plant, it is the rare cannabinoid that you can't get right now in a lab. Doesn't matter what you're producing, the cost remains the same. So again, that's making an argument for there is a place for synthetic cannabinoids within the cannabinoid family, if you will. There are a few problems associated with synthetic cannabinoids as well. Isolated cannabinoids act differently in the body than naturally occurring plant cannabinoids, plant-based cannabinoids. The health effects from using synthetic cannabinoids can be unpredictable and harmful, even life-threatening. So adverse reactions include rapid heart rate, vomiting, agitation, confusion, and hallucinations. And those are some of the adverse reactions that we'll actually see with high doses of plant-based THC as well for some people. So oftentimes these synthetic cannabinoids are so potent that they become dangerous, right? So we have the therapeutic window is very small on them, how much you take for that. A lot of the synthetic cannabinoids were actually created to be sold on the illegal market because they happen to be less illegal than the plant itself. A little backwards, but anyways, here we are. But there also can be contaminated with some toxic ingredients that show up as street drugs. So some of the names of those are K2, Spice, AK-47, Mr. Happy, Scooby Snacks, Kush, Chronic. Those are sort of synthetic cannabinoids that have maybe been put with some other products to create recreational drugs that are actually quite dangerous. The other problem with synthetic cannabinoids is there's no smell, taste, and other kind of tactile aspects of the plant medicine itself. And those actually provide very subtle benefits for patients when they're taking them. We often don't think of smell and taste as being part of the medicinal action of some of the medicines that we're taking, but they actually trigger things in the body that we don't really understand. Just the routine of preparing your own cannabis for use. So for some people, especially if they're using cannabis for PTSD or chronic pain, part of that whole act of, say, rolling a joint or preparing the cannabis, grinding it up, putting it into a vaporizer, that kind of preparation method is actually part of a healing routine for people. It helps their body prepare to receive the medicine. So again, we're kind of getting just kind of tiptoeing into the spiritual realm of how plant medicine works in the body, but it is an important aspect that we shouldn't overlook either. So, synthetic cannabinoids do have their place as medicine, but there really is something to be said for the tactile presence and the smell and the taste of using plant medicine itself. We have some pharmaceuticals that have come out of, that are created using synthetic cannabinoids, and these have been on the market for quite a while, both in Canada, the United States, and around the world. Dronabinol is the name of the chemical, the synthetic chemical, and the brand names are Marinol and Syndros, or a couple of brand names that you find this one. This is a synthetic THC. It was approved way back when for HIV/AIDS-induced anorexia and chemotherapy-induced nausea and vomiting. So it was helping to stimulate the appetite for people who are undergoing chemotherapy or maybe have their health has just been weakened from HIV/AIDS. It was rescheduled in 1986, so you can see this one has been around for a long time, from a Schedule 1 to a Schedule 2, and then again rescheduled from Schedule 2 to Schedule 3, basically acknowledging that THC has less potential for abuse than cocaine and heroin. Yet we still have THC from the plant itself in the United States scheduled as Schedule 1, which basically means high potential for abuse and no medicinal value, which I think has now been proven that is just not true. So it's just going to be a matter of time, is kind of working through those politics. This one is used off-label. So on-label, it's used to help with nausea and vomiting. It's also used off-label as an analgesic and for neuropathic pain as well. Our second synthetic cannabinoid pharmaceutical is Nabilone. You can also see that as Sesamat. Synthetic THC, also indicated for chemotherapy-induced nausea and vomiting and other cancer treatments. This one has also been used off-label to treat glaucoma, spasticity in multiple sclerosis, wasting disease due to AIDS, and chronic pain as well. So the same thing that we would use plant-based THC for, there's a synthetic pharmaceutical product out there. There is a couple of prescription drugs made from the cannabis plant. So this is basically legalized cannabis, even though the plant itself is still outlawed, or it was outlawed up until recently. And so Epidiolex is high concentrated CBD from cannabis, and that's used to treat seizures in children over 1 year. And Sativex is another one that's a mouse spray, and that has an equal amounts of THC and CBD in it, so it would be considered a balanced product. Used to treat spasticity in patients with multiple sclerosis, and it's used off-label for pain in cancer. So again, we see just because it's a prescription drug that's been around for years, the plant medicine will do exactly the same thing. It's just not in prescription form. So yeah, again, interesting how these things have come out. Biosynthetic cannabinoids are a kind of the new kid on the block. They're kind of natural cannabinoids, so they're not created using chemicals in a lab. They're actually grown, and they're grown using genetically modified yeast. Now, that might sound weird and gross, but a lot of our probiotics are actually grown on genetically modified yeast as well. It's a really good way to grow a very consistent product, whether it be probiotics or whether it be cannabinoids. Now we're sort of starting to delve into that area. Some of the benefits of biosynthetic cannabinoids is much faster production versus having to, wait for, several weeks for a cannabis plant to grow, and then you have to go extract out the cannabinoids out of it. We can grow that in a lab in this yeast in 5 days versus 6 months. So much faster production, of course, less environmental impact versus growing in big greenhouses or big rooms where you have light and temperature control, humidity control. That all takes a lot of electricity and resources. So it's actually a really promising new technology. It may be lacking in some areas where plant-based cannabinoid medicine might be a much, a more well-rounded medicine for some issues, but we also may be able to get very targeted cannabinoid-based medicine on the biosynthetic cannabinoids. Now, I don't know. There may be some of these on the market right now, but I believe it's a very new technology. And so I'm not sure that we're actually seeing anything on the market yet, but I may be wrong about that. I couldn't find any, but there could be something out there. But certainly in the next few years, we'll start to see some of the biosynthetic cannabinoids or these cannabinoids that are grown on yeast starting to hit the marketplace. And I think it's pretty exciting. I think we might be able to get some really interesting targeted medicine out of it. So that is other types of cannabinoids that exist in both nature and in laboratories. And yeah, this is a pretty interesting plant. I guess you're figuring that out now.